Hi, my name's Jasmine. Welcome to Bulldog Bound 3E. This is Spike. Today we're going to participate in a workshop that highlights one of the programs you can study when you're a student here at Allen Hancock College. We're going to spend 20 minutes learning from one of our professors about what they teach here at school. And we're going to be doing some cool activities. Remember that Bulldog Bound is part of the Hancock Promise program. If you graduate from one of the high schools within the Allen Hancock Joint Community College District, you'll be eligible for the first year free at AHC. Stay with me, first year free at AHC. All right, let's head off to our workshop.
Welcome everyone to the Chem Dogs workshop. My name is Danae Madrid. I'm Associate Professor of Chemistry here at Allen Hancock College. We're so happy for you to join us today. So what do I do? Well, I work in a chemistry laboratory and I work my students through different types of experiments. We make observations, we ask questions about why things happen. What if you go into the STEM field? Any type of science, you're going to be doing the same thing. You're going to be implementing the scientific method, probably like you already do in your everyday life. You make observations, ask those questions, test, make hypotheses, gather data, and then reevaluate what that data means. If you go into chemistry, what might you go into in a profession? If you're studying chemistry, you could go into the medical field. You could be an instructor like me. You could be on the forefront of implementing some type of administering a new type of medication. There are various different fields or various different types of careers that you could go into. But let's start small first. Let's say you're at a party with your family and your parents have put in some sodas into a big ice chest. But over a period of time, the ice obviously melts into liquid water. What do you see happen? So think if you have a diet soda and a regular soda. What would you see in the water? Some people might say, well, if I put these sodas in the water and after the ice melts, both of them are going to float. Other people might say, well, no, they're pretty heavy. They're both going to sink. Let's actually see what happens. Let's put in the regular soda first. Looks like that went to the bottom. Okay, what about the diet soda? That floats. So you might ask the question, well, why is that? Well, what's the difference between these two sodas? The regular soda has sugar. The diet soda doesn't. What are we actually analyzing here? What makes them different? It's the concept of density. This diet soda is less dense than the water. This regular soda is more dense than the water. These are fundamental foundational principles for us to understand when we go into any type of science field. Let's take it to another level and look at something more visually appealing. So 4th of July, most people see fireworks in the sky. The reason they are so appealing to us is because they're bright, they're flashy, they have a lot of color. But how do scientists actually construct these fireworks to make them so appealing? Well, they actually use metal salts. So what we've done here is we've taken some metal salts and dissolved them in methanol. Methanol is an alcohol that is very flammable. So if I actually spray this, I don't see anything, right? But let's say I add in some energy, some type of heat energy to this spray. What will we see happen? I'm going to take this propane torch and light it if I can. There. I'm going to hold it to this side very carefully. I'm going to take calcium metal on the periodic table and spray it. See what happens. See that bright orange color that forms? That is characteristic of calcium. Now, we might see a different color when we do lithium. What does lithium look like? It's a characteristic red or bright pink color. What about strontium? Strontium is one of my favorite. It looks similar to lithium. kind of a more orange pink. Now barium has a very characteristic green color. And last but not least, we do sodium. Sodium has your more orange color. So anytime you are looking at these fireworks, whenever you see those characteristic colors, that tells you that that particular metal is inside that firework. Remember, all of the demonstrations we do today should not be tried at home. They are only done in the lab under supervision of an instructor. Welcome to our gummy bear sacrifice demonstration. What I am going to do right now is I'm going to heat up a solid of potassium chlorate. When it's completely melted, I'm going to take our little gummy bear, something that you might eat on a little snack. I'm going to put it into that completely melted potassium chlorate, and we're going to see what we call a combustion reaction. So you know that gummy bears are mostly composed of sugar, right? That's a lot of carbons, a lot of hydrogens, a lot of oxygens. Just like what happens in your car vehicle when oxygen comes into contact with the fuel and there's a little heat put into the process, a combustion reaction occurs, and that releases carbon dioxide and water. So we're going to see if we can do that with our little gummy bear here. I just have to make sure that this is completely melted, and then our little gummy bear is going to do some tricks for us. So let's see what happens. So this is almost completely melted. If you were zoomed in anymore, you could see that it's actually bubbling. Want to make sure there's no solid left. I'm getting it really hot. All right, so I'm going to take some tongs, and I'm going to place this in. Oops, don't drop the gummy bear. I'm going to place it inside. Nope. He was sacrificed for a good cause. You can see it illuminates light. It's decomposing. You're going to see a little black speck at the very end, at the very bottom. That's what's left over of our gummy bear being decomposed, of being combusted. Same thing you see in a fire pit. All that black at the bottom, that is one of the products of an incomplete combustion. Everything else you saw go outside of the test tube. There's water, there's oxygen, vapor, and there's also some smoke. That is the carbon that's left over from our little gummy bear. So that's our gummy bear demonstration. Welcome everyone. We've switched to an outdoor setting for our next two demonstrations because you'll see why. Here we are going to generate some toothpaste. You're obviously familiar with the toothpaste that you use at home, but what would an elephant use if they were brushing their own teeth? Well, I'm going to use some potassium iodide, and I'm going to first place this into our flask. Now notice, while I'm doing this, I'm wearing gloves. I have eye protection, and I'm going to be standing away from this reaction. Anytime you're doing this in any type of lab, you should also employ the same techniques. I'm going to add just our regular old Dawn dish soap. I'm going to add it straight, actually. I like a lot of elephant's toothpaste, so let's do that. And then I'm going to add just your everyday, ordinary elephant's blood that you have laying around the house. So I'm going to pour this inside as well to give it a rich red color. Ooh, I like that. Take my little funnel out. Now I'm going to take hydrogen peroxide that's usually found in a brown bottle at home. This will hurt your hands. So even if you're just dealing with hydrogen peroxide at home, unless it's a very, very low percentage, I would suggest not putting this on your skin. So I'm going to add this to my flask after I remove all of my other chemicals. And there we've generated a good amount, a really good amount of elephant's toothpaste. still coming. I can market this for so much money. I'm kidding, you really can't. But let's pretend that we're gonna have an elephant here soon and they're gonna take this and use this to brush their teeth. If you were here, you could feel that it's very, very warm. There's a lot of heat that's leaving. This is the decomposition of the hydrogen peroxide. Hydrogen peroxide already decomposes at home in that brown bottle that you have. If you leave it out, it will decompose into water and to oxygen. But what I've done is I've taken a catalyst, that was the first bottle that I used, and I really sped up that reaction. Add a little coloring to make it more appealing to the eye, and this is what you have. Welcome to our final demonstration and my personal favorite, the Thermite demo. In here, I have some aluminum, it's a metal, some aluminum powder. I also have some iron 3 oxide. Those two are going to undergo a reaction with each other. They're actually going to switch places. We're going to generate pure iron, which is very hot, and you'll see it dripping down. You're also going to be generating aluminum oxide. But in order to start that reaction, I need a lot of heat. So what I have inside this pot on top of my iron 3 oxide is some potassium permanganate. It is what we call oxidizing agent, which means very flammable. Gets really hot when it actually combusts. In order to start that reaction, I have this little gooey stuff in this tiny beaker called glycerin. I'm gonna pour that on top. It's gonna take probably about 2 to 2.5 minutes for that actually to start reacting. Once the glycerin and the potassium permanganate react with each other, they will set off a second reaction. So look for smoke and some flames. All right, thank you everyone for tuning in to Chem Dogs. I hope this inspired you and made you want to look more into the sciences and specifically chemistry. Again, don't try these demonstrations at home, but ask an instructor or someone else around you that maybe in lab one day you can experiment with these things yourself. Thank you and have a great day.
Thank you for participating. We hope you enjoyed the workshop. Remember, first year free at AHC. Go Bulldogs!